In this video, we introduce some of the basic concepts behind the internet and how it works. The internet is the most widely known wide area network. It is simply a collection of interconnected networks that span the world. People often think of the internet as the World Wide Web, but in reality, this is just a service on the internet. The internet itself is just the hardware, the cables, the wireless connections and the routers that make the internet what it is. In this image, we see a representation of what the internet actually looks like. Each white dot represents a router, and each coloured line a connection to a router. You can pick out star shapes that are local area networks. This is a simplified diagram of what a very small part of the image may actually look like. Our home network has a number of devices connected to a wireless router. The home router is connected to an internet service provider router, either by telephone connection or fibre. Our internet service provider is connected to a domain name server and to other routers on the backbone of the internet. And those routers are further connected to their own LANs and other routers and servers. Typical uses of the internet include browsing web pages, pages of information connected together with hyperlinks that can be read using software called a browser. Web pages are held on a web server. Each server is connected to the internet with a router and therefore has an IP address. When you request a page on a server, you would need to refer to its IP address. Now, this is not very convenient for humans as we're not very good at remembering sequences of numbers. We prefer to use words. For example, the BBC web server may be at IP address 212.58.244.67, but we would prefer to remember a URL such as bbc.co.uk. Special servers on the internet called domain name servers convert a URL into an IP address for the routers to use. As websites need to be on a server that is always available 24/7 and may have to serve the page thousands of times a second and be secure from hackers, they tend to be stored on servers called web servers that are dedicated to this task. Storing a website on a web server is known as hosting. Servers can also be used to store data and programs that can be accessed and used over the internet. Now, you're not actually going to be asked about web servers and clients in the exam as it's not in your specification, but we think it's really useful to understand when you're learning about the internet as a whole. You will, however, be asked about your understanding of IP addressing and packets. Now, we've recreated the diagram from earlier but added a few more details. You can see here we've given every device an IP address, and that's highlighted in green. An IP address, or simply an IP, is a unique address just like the address of a house, and it identifies a device on an internet or local network, just like your address identifies your house in a street or town. It allows a system to be recognised by other systems connected via the TCP/IP Internet Protocol. Data that's sent across networks is often split up into separate individual packets for transmission. Now, due to the way the internet works, packets can actually arrive out of sequence. The header of every packet can contain additional information. For example, every packet will include the address of the sender and the address of the destination, and this helps the packet make its way across the internet. It also contains what's known as a sequence ID. For example, here we can see the router in the bottom left is sending a message made up of 4 packets, and we've sequenced them with the IDs 1, 2, 3 and 4. This means the packets can be reassembled into the correct order once they arrive at the destination. So here we can see that each packet has taken its own route across the internet, perhaps due to the difference in network traffic and latency at the time the packet reached each node, and as a result, the entire message has arrived out of sequence. This doesn't matter though, as the destination device can use the sequence ID in the packet headers to reassemble the message correctly. Now, we actually take a much more detailed look at how this packet transferring system and headers and IP addresses works at the end of the video on TCP/IP protocol model when we go beyond the GCSE spec. So if you're particularly interested in this area, you can find out more information on that in the later part of that video. Okay, so here's a summary of everything we've discussed. Pause the video and take some notes.